class, we have solved this type of problem, uh, wherein we have designed the slider crank mechanism for its three position by using the Freudenstein's equation. Okay, so I have told you that at the end of any problem that you get for Freudenstein's slider crank, this is the form that you need to get in, wherein you will be having the various theta 2 values for position 1, 2, 3, and various slider positions, that is S1, S2, and S3. So once you get it in this format, then you can just use the standard Freudenstein's equation and get the values of K1, K2, K3, and accordingly Z1, Z2, Z3, and Z4. Okay, so this was all about how to solve the slider crank mechanism using Freudenstein's equation. In the next category, let us take this one, that is how to synthesize or design the crank rocker mechanism. Okay. So we have done crank slider. Now let us focus on the crank rocker mechanism. See, the derivation for this is actually not a part of your syllabus. So as of now, I'll be starting with the numericals. But of course, in the next class, I'll be still taking up the derivation of this because it is very simple. Just like the slider crank only, we are going to derive for crank rocker. The derivation is very much similar. But as of now, in today's class, since the strength is also less, so I'm not taking up the derivation. You can just note down the Freudenstein's equation for this, that is the crank rocker mechanism. Okay. So the Freudenstein's equation is given by K1 cos of psi 1 plus K2 cos of phi 1 plus K3 equal to minus of cos of psi 1 minus phi 1. So this is our equation. If you notice in this equation and the previous slider crank equation of Freudenstein, so in the slider crank, which we have done in the previous class, only the parameter was theta 2, that is angle of the crank. But now here I have two parameters, that is one is psi, which is nothing but the moment of the input angle, and another one is phi, which is moment of the output angle. So I hope you can understand why this is coming. So if I take a 4-bar mechanism or the crank rocker mechanism in this fashion, so the input link has to rotate by psi value, and the output link has to rotate by phi value. In earlier case, since there was a slider, we didn't get that phi angle. But here there is a rocker, so the rocker can definitely rotate with respect to the pivot point, and the angle is represented by phi. So in this above equation, you can write the same equation 3 times. In the second equation, you will have to just replace psi 1 by psi 2 and phi 1 by phi 2. Similarly, the third equation, you can again write psi 2, psi 3 and phi 3. Okay, so let us take up the problem so that it will be more clear to you. Synthesize a linkage using Freudenstein's equation to generate the function y equal to sine of x within the range of 0 to 90 degrees. Range of input angle is 120 and range of output angle is 60 degrees. Okay, so this is the problem statement given to us. Yeah, out of the 5 students who are present today, I just wanted to know, are you guys also solving the problem along with me, or you're just observing? How?
Sir, we are solving.
Okay. Have all of you have noted down the problem?
Yes, sir.
Okay. Coming to the solution of this, let me first write what is given to us. We have the function y equal to sine of x, and the range is between 0 to 90 degrees. This is the range. Plus, they also given you delta psi, that is range of input angle, as 120 degrees, and delta phi, that is the range of output angle, that is 60 degrees. So this is the given data to us. Now, if you just look at this Freudenstein's equation over here, which I have written at the top. If I want to use this equation, I should be knowing what is psi 1, psi 2, psi 3 and phi 1, phi 2, phi 3. Only then I can use this equation. So to understand or to find out the values of psi 1, psi 2, psi 3, which are also known as the precision angles, I should be knowing the value of x1, x2, x3 and y1, y2, y3. Those are nothing but the precision points. So I'm just working it in the reverse way. Okay, to get precision angles, you need to get precision points. So how do we find out the precision points? By using our Chebyshev method, that is delta xj will be equal to delta x by 2, 1 minus cos of pi into 2j minus 1 divided by 2n. What is n here? N is not given,
Total
but
number of precision points. Yes.
yeah, but it's not given, right? But you need to understand that if at all we are using Freudenstein's equation, okay, and by default the value of n will be 3. How can I assume this? But if it is Freudenstein's, I am saying that n is equal to 3. That is because if you look at the Freudenstein's equation, as I said, I have to write these three equations by replacing psi 1 by psi 2 and psi 3 and so on. So I'll be having three equations and I'll be having three unknowns, that is k1, k2 and k3. If at all I take precision points as 4, then I will get 4 Freudenstein's equation. Okay, with 3 unknowns. So solving will become again tedious at that point of time. So by default, if it is not given to us, then we are taking the value of n for Freudenstein's equation as n equal to 3. So now you no need to solve this and find out all the values. I have purposely taken this function y equal to sine x. So if you just turn back your pages or refer to the 3 position and 4 position synthesis that you have done in the previous chapter, we have already solved this problem. Okay, so the values that we have got is, say x0, it starts from 0, and x1 we had got it as 6 degrees, x2 is 45, x3 is 84, and x4 is 90. So these are the 3 precision points, and x0 and x4 are the extreme points. Similarly, based on this we can also find out the values of y. So y0 will be 0, y1 is 0.104, y2 will be 0.707, y3 is 0.994, and at the end y4 will be equal to 1. I hope you can remember these values, or you can just refer to the problem that you have solved in the previous chapter. Are you getting this?
Yes, sir.
So I'll proceed to the next step now. Once we get the precision points, then I can find out the precision input angles. So we have the equation psi j will be delta psi divided by delta x, xj minus x1. So this is our equation. So you can find out what is psi 2 by replacing xj by x2. So you know what is delta psi, it is already given in problem. Delta x, you know that it is 90. Okay, xj means it is x2 here. You know the value of x2 and you know the value of x1 also. So if you just solve this, you should be able to get this as 52 degrees. Similarly, you can also get the value of psi 3. It happens to be 112 degrees. We can also find out the output precision angles. Same thing, phi of j will be equal to delta phi divided by delta y. In the bracket it will be yj minus y1. So if you substitute the values, you should be able to get what is phi 2. Can anyone tell me how much you are getting? Phi 2 and phi 3. Or if you don't want to calculate, I can give you the answer. Yes, how much you are getting? 5 2. Are you unable to calculate or you don't want to give the answer? What is the reason?
Sir, calculate.
How much time it requires to calculate? Delta phi is already given to us 60. What is delta y? 1 minus 0, it is 1. What is yj? Yj means y2 you have to take. So y2 is 0.707 minus y1 is 0.104 is given to you. So to put this in calculator, you should not take more than 10 seconds also.
Sir, 36.18.
36.18. Similarly, phi 3. So in phi 3, only thing is instead of yj, you will have to put y3 there. So the answer that I'm getting is 53.4.
Yes, sir, same answer.
Now just let me plot this rough sketch of these precision angles of what we have got here. So let me write this as A1, A2 and A3. See here, I have got psi 2 as 52 degrees. So where should I mark this 52 degrees? If you look at the formula, this psi 2 has been found out with respect to x1, that is the first position. So which means this angle is 52 degrees. Similarly, psi 3 we have got 112 degrees. That 112 degrees again it is with respect to x1 only. So this angle is 112. Okay, so this is what we have found out now in this fashion. But to use Freudenstein's equation, I would want to measure the angles in other way. That is, let me show you here. Once again, say this is A1, A2, and say this is A3. What I want is these angles. This one should be my psi 1. Okay, psi 1 is the angle made by the first position with respect to horizontal. Similarly, psi 2 is the angle made by the second position with respect to horizontal, and psi 3 should be the angle made by the third position with respect to the horizontal. So this is actually what I need. This is what we have got now here, and this is what we need, because I need to put psi1, psi2, psi3 in the equation. Can anyone tell me what should be the actual values of psi1, psi2, psi3 now?
So psi1 we need to assume.
Exactly. So psi1 is nothing but our initial position, which can be anything. So you can assume this value of psi1 anything. So let's say, let me assume this as 40 degrees. Okay, so this is based on assumption. Similarly, psi2 will be 40 plus 52, right? That is 92 degrees. And value of psi3 will be once again 40 plus 112 degrees. That will be 152 degrees. Okay, so I got the actual values of psi1, psi2 and psi3 now. I hope this concept is clear. There is no doubt here.
Yes, sir, it's clear.
On the similar lines, we can also find out the actual values of phi. So again, phi1 is not given to us. We need to assume it. We can assume any value. Say, let me assume this as 60 degrees. So this is again assumption. Then what will be phi2? It will be 60 plus 36, what you had got. So I'm getting this as 96 degrees. And phi3 will be again 60 plus 53.4. So that will be 113.4 degrees. Okay. So based on this, let us write the Freudenstein's equation now. So already you know the standard equation, or let me write it once again for you. K1 cos of psi plus K2 cos of phi plus K3 equal to minus cos of psi minus phi. Okay, this is the standard equation. I'll write it 3 times now by replacing psi with psi1, psi2, psi3, and for 3 equations, and similarly phi with phi1, phi2, and phi3. So my first equation will be K1 cos of 40 plus K2 cos of 60 plus K3 equal to minus cos of psi1 minus phi1. That will be 40 minus 60. Similarly, second equation will be once again K1 cos of 92 plus K2 cos of 96, that is phi 2, plus K3 equal to minus cos of 92 minus 96. Third one, K1 cos of 152 degrees plus K2 cos of 113 degrees plus K3 will be equal to minus cos of 152 minus 113. So these are the 3 set of equations that you'll get from Freudenstein's equations. So now you are having 3 equations and 3 unknowns, that is K1, K2, K3. So just solve this and let me know what are the values of K1, K2 and K3.
So K1 is minus 0.53,
Minus 0.53, K2
K2 is 0.81,
0.81, yes,
and K3 is minus 0.93.
0.96, right?
93, sir.
So what happens is if the initial assumption of your psi1, I have taken it as 40, and initial assumption of phi1 I have taken it as 60. So instead, if I take psi1 larger than phi1, then what will happen is you will get K1 and K3 as positive values and K2 will become negative. But that should not actually change your answer. You can still synthesize this mechanism only. So these are the K1 values. We still need to get the values of Z1, Z2, Z3 and Z4. So the formulas I'm directly writing it. We are not deriving it here. So I'll just write here where K1 is given to us as Z1 upon Z4. K2 is given as minus Z1 upon Z2, and K3 is given as Z3 square minus Z1 square minus Z2 square minus Z4 square divided by 2 times Z2 Z4. So these are the equations. Can you find out the link lengths directly by using these equations now?
No, sir, like we need something.
So you cannot actually find out the values of Z1, Z2, Z3, Z4 directly here. Out of these, you need to assume at least any one. So for example, if I assume Z1 over here, I can find out Z4. Or if I can assume Z4, I can find out Z1. And then go on finding out the other values. So at least one length you need to assume. So let us write that let Z1, so let it be around 50 mm. This is what I'm assuming. One link length I have to assume. So now I can use this equation wherein I know K1, wherein I know Z1. So I can find out Z4. So how much you are getting Z4? Z4 will be 50 upon K1.
So minus 94.33.
What about Z2?
So minus 116.41.
Okay, minus 116. Yes, for Z3.
So 67.09.
Okay, so these are the values of all the four links. Can anyone tell me whether these are a scalar or whether these are vectors?
Sir, they are vector quantities.
How do we justify this? See, what is Z1 actually? It is a link length. When I'm saying only length, then it will have only magnitude. While derivation, we have taken them as the vectors. Okay, but ultimately, when you synthesize a mechanism, this means only the link length. I hope you are getting my point.
Yes, sir, got it.
At the end, it is only the link length. So for drawing the mechanism, I'm going to just take the modulus of this. That means automatically this minus sign doesn't mean that you have to draw it in any opposite direction or something like that. The magnitude of that length will be still same, that is 94.3 only. And even the same thing goes for Z2 also. But if you don't want your final answers to be in this negative, though it will not make any difference, you can still construct the mechanism by taking these values. But if you want to ensure that these are not having any negative values, then as I said, in this assumption, what you do, that is wherein you assumed psi 1 as 40 and phi 1 as 60. You can just ensure that the value of psi 1 is greater than phi 1. So if you solve it using that, you will just ensure that all the values at the end, you are going to get it positive. So if you want, you can just try it out. Instead of this 40, you can just make this as 100. If you assume phi 1 as 100 and psi 1 as 60 only, then all your final answers of z will automatically come as positive. But right now, even this is still a correct answer. Okay, we'll stop the class here. In the next class, we'll take up one more problem on this and the derivation also on this equation, that is Freudenstein's for crank rocker mechanism. If you have any doubts, please let me know, or else we can wind up the class. Okay, thank you.
Excuse me, sir.
Yes.
Sir, actually, from past 1 week, I could not attend the classes because of some reasons. Sir, I had some project work.
Okay.
So, sir, I'll go through all the videos once, sir. If I get any doubt, I'll just contact you
Sure,
to you.
sure, sure. No problem.
Okay, sir. Thank you, sir.
And I've also posted the syllabus in your classroom. So the syllabus for your second eye, uh, we are going to have entire unit number 3. Okay, that includes 2, 3, and 4 question synthesis. And I'm also planning to include this Freudenstein's numericals. That is up till whatever we have done today.
Okay,
That will
sir.
be included in your second eye.
Okay, sir. So, 2-4 synthesis, matlab that day which you had taught us before, I that only, no, sir.
Yes, 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 exactly.
Okay, okay, sir. Thank you, sir.